start now. So basically, we need to go to our lab now,
Okay.
lab requirements. So we need to understand the what things first we need, and so for that, so this will tell us about that thing. So basically, what are the things which we need for our lab purpose?
Mm-hmm.
So basically, um, of course, we need a AWS
Mm-hmm.
cluster, and we need a we need a VM on
Mm-hmm.
our PC. We need a Ubuntu
So,
machine or spin up on it
oh,
AWS
this all
machine,
we want in AWS.
and
Okay.
yes, yes, and VM will be on our PC on our local
Mm-hmm.
laptop,
Mm-hmm.
so that we can SSH to that
Okay.
Ubuntu box.
Just,
And
dude, just give me
yeah,
1 minute.
yeah, yeah, yeah. So coming on to this, so we need, of course, Ubuntu machine, and we also need softwares. So softwares we need like ConjureUp.
Mm-hmm.
So ConjureUp is like these softwares like they help us to spin up a cluster. I mean, we can do all these things manually, but with these softwares uh, like this kubectl and Juju
Oh wow,
cluster
Juju's
and
Juju's
so
back.
yeah, so we to give it a
Mm.
startup, to give it a head start, these things
Okay.
helps. So yeah, and yeah, so and we also see what is a TLS connection, what
Mm.
happens we,
Okay.
over there. So this is pretty much like a software requirements. So let me see what else we need. Yes, so we need to sign up for an AWS account,
Yeah, I
and
already have one signed up
we need to. You already have one.
with
Okay,
your
signed up.
grace.
Okay, so awesome. So yes, so and we also need to download. We need to get the security
Mm-hmm.
credentials, and we need to get the access keys. I mean, it's a. You can just hover to your mouse and you will just find it. So over your account name, and
Mm-hmm.
then you will find it. And you need to download that CSV key
Mm-hmm.
file to your computer, and don't share it with anyone because if you share it with someone, then anyone can have access to your control
Mm-hmm.
AWS account. And yeah, so that is important. And uh, um, yeah, so just generate a new set
Mm-hmm.
of root keys, uh, and that's pretty much it to just to start up. I mean, we will start with all these things surely
Okay.
from next session. And yeah, and so you already have an AWS account, so that's great. But just get this root key, AWS root
Mm-hmm.
key, and then we
Good.
should be
Okay.
good to start. Yeah. And what else we need? Vagrant is a tool. Basically, it helps. We will see if we might not need
Mm-hmm.
this. But so this is another like a. Uh, basically, it lowers us the VM setup time, so we can use the. I mean, we can use the Oracle box as
Okay.
well. But with like what Vagrant does is basically with one command we can provision the VM. So we might not need this. So I'm just giving you for information that we
Okay.
might need it. Uh, YAML editor. So Sublime editor is a very good editor. Sublime text is available for
Okay.
free. Mm, so it beautifies the editor and it beautifies the YAML file. So rather than or Notepad plus plus is also good, but usually Sublime text is uh, like mostly in
Okay.
companies we use
Okay.
it.
Okay. Okay.
Sublime text.
Sublime text, huh?
It's a,
Okay.
yeah. I'll share this PPT with you.
Yeah. Yeah.
Not
Okay.
to worry. Yeah. Yeah. And again, just a refresher. Like our cluster will have like a master and a
Mm-hmm.
worker node, and we node is a basically a VM or a
Mm-hmm.
physical computer. In the diagram, it shows like there's
Okay,
one
okay,
node, and there even in the production cluster, it has only one
okay,
master
okay,
node,
okay.
and this master node basically this master node has three major components. One is API server,
Uh-huh.
Kube API server. One is Kube
Okay.
control manager, which controls the loops basically. You remember we basically to maintain the state
Mm-hmm.
of the system. This guy
Okay.
is responsible, Kube control manager, and Kube scheduler. So basically, it just it's responsible for workload
Okay.
placement. Master basically what are the main major activities of master is basically it schedule the pods onto over
Mm-hmm.
the worker nodes and basically and it maintains the desired state on basically the cube's control
Mm-hmm. Okay.
manager does that and
Okay.
scaling of apps and so all this is done by
Okay.
the master. So we don't deploy the app on the master. We will see
Okay.
in later. So basically, you might have heard this term
Mm-hmm.
high availability. So high availability cluster. So basically, all these machines, like all these nodes and
Mm-hmm.
this master node, they are all basically they are connected
Okay.
via network. And to just to have a like to facilitate
Mm-hmm.
the connection
Mm-hmm.
between them. And that network is called like a TLS connection, which we have shown
Okay.
in the
Okay. Yeah.
previous
Yeah.
slide. So that
Okay.
TLS connection,
Okay.
yeah. And kubectl, so basically it's like a command line. We
So
call it
we
a
will need
command
to
line.
do the
And
security configuration between all these. I mean, with master
we
and
don't, yeah,
slave or the worker nodes and stuff. Or
um, yeah. I mean, mm, actually, yeah, we need to do it. We need to do that setup. But we are using this ready-made production cluster,
mm-hmm.
Conjure Up software. So that
Mm-hmm.
will do for us. But in companies, yes. So we need to set up the basically all these. We need to set up all this Kube API server, Kube
Okay.
control manager, and all these major components like uh, what does Kube API server does? Basically, it serves the front end. It provides like a front end
Okay.
for this cluster. And what is kubectl? So we have to install the kubectl as well, so that master node can actually communicate with the worker
Mm-hmm.
nodes. Basically, kube API server process because that is the front end
Okay.
for the cluster. So kube API server will communicate with the
Mm-hmm.
nodes with using kubectl command. So we need to do all
Okay.
that manually if we are starting from scratch. But if yeah, and but once we have this, I mean these components like
Mm-hmm.
Kube Control Manager, as it's written here, like it's a non-terminating loop
Mm-hmm.
basically. So basically, you define your state in the YAML file, and this guy will be responsible to maintain that state
Okay.
always. So uh, you need not to worry about to maintain the state. This Kube Control Manager will do that. Once we configure that. So basically, uh, like suppose
Mm-hmm.
replication controller or name. I mean, there are a few examples which has been mentioned here. Like what are the components of Cube? I mean, what are the components of control manager itself? So there are like replication controller, endpoints controller, namespace
Mm-hmm.
controller, and service accounts
Okay.
controller. So uh, those are the tenets of this
Okay.
one control manager. Now the third processor is basically
Mm-hmm.
Cube Scheduler. So what it does is it schedules all the pods into
Mm-hmm.
the nodes. So your app resides into the
Okay.
pods, and pods are on the nodes. So node is nothing but a
It's a
worker.
worker node.
Basically,
Yeah. Uh,
it's a
okay.
worker node. Yeah. So basically, pod will contain the actual app.
Pods
So
will have
basically, pod is a collection of
one. Okay. Okay. Okay.
yes. It's an basically it's an atomic unit of work. In it's like a DNA of Kubernetes
Mm-hmm.
actually. So it's an atomic atomic form, atomic
Okay.
unit actually. And so that's pretty much it. Like we need to know about all these cube. At least theoretically, we should know like what what are the major tenets of
Okay.
master node. So API server, control manager, and
Mm-hmm.
scheduler are the important uh, things. If someone asks you like what do you understand by a master node, then you should be in a position to explain
Terminologies.
all these three tenets.
But I was
Yeah.
wondering,
So
so part is on the worker node, okay.
yes,
So I was wondering how this
and
works in the service oriented architecture, right? Like microservice architecture. Let's say there are 20 microservices form a cluster, right? For example, if
mhm,
that is what the application is
20.
comprised of, not just 20. I mean, I
Yes.
just want to take a
So
number 20 and
yes. So when we say services, so I mean that's a
Mhm.
application service. So we are and so we are basically uh, developing our code and exposing it as a
Okay.
service. So the yeah, so if we are building using Kubernetes cluster, then we need not to worry about that because we those service comes those service are containerized basically. Those are containers. So those are deployed as a doc
Mhm.
as an image or a container to a pod.
Oh, okay.
So
The pod
and this
will
pod
have a combination of all those services as
yes.
image in the container.
Yes, and
Those images will be there. Okay.
yes, and this Cube API server, Cube
Uh,
controller manager, Cube scheduler, they are also
okay.
APIs, but they are like they are like the skeleton of the cube of the
Okay.
master node. So I mean, as a developer, as an
Okay.
application developer, people will not they will not have access to all these things like Cube API server or Cube control manager, scheduler. So all they care is just
Okay.
do their work and expose it as
Okay.
a service and basically so and just deploy it to Kubernetes cluster. And from there, um, like all these applications will be running at the node at the worker node and not at the
Mm-hmm.
master node.
Yeah, yeah. The pods will be running
I
on
mean, we
the
never
worker nodes
deploy.
or on the.
Yeah, yeah, we never deploy anything
Okay.
on master actually. So uh, yeah, so we can this pod is basically a collection of containers
Mm-hmm.
and volumes. So volumes is basically nothing we it's basically the drive volumes. You can specify like like you need a 1 GB volume or 20 GB volume. You can specify in the YAML file, and then Kubernetes will make sure that okay this much amount of memory or has to be given to this
Okay.
particular app. So yeah, so that pod will take care
Uh-huh.
of that. Pod, I mean, yeah. So basically, your container, your app, you want that okay, my app will always need one
Mm-hmm.
gig of RAM,
Mm-hmm.
1 gig of volume. So you will always have this one gig like this loop, right? This queue
Mm-hmm.
control manager. Uh, Basically, it will control the loop. So it will make sure that your application always has 1 GB of RAM, always. So it will make sure that it will maintain that state of the or of your
Mm-hmm.
application into the cluster.
Okay.
So yeah. So that's a little we should know about these things. And as we discussed, like actually worker nodes run the
Okay.
apps in pods, and they are the load bearing machines. So
Mm-hmm.
all the heavy lifting is done by them. So when we run any performance testing or we done we whenever we do any uh, like transactions, so all the transactions of the applications, all those happens at these machines, at these
Mm-hmm.
worker nodes. and these worker nodes will have
Okay.
a kubelet
Okay.
running in them, and this will have a Docker
Okay.
as well uh, to maintain the container operations. That's it. And as we discussed before, containers are not scheduled on master. It will always be running on the
Okay.
worker node and
Yeah.
basically
Yeah.
Docker
Okay.
container.
Okay.
So we should be every production cluster will have a minimum of one master node and
Mm-hmm.
three worker node. That is the bare minimum
Okay.
you will see. And basically kubelet, when we discussed kubelet, like basically it's a
Mm-hmm.
daemon process which is works on
Mm-hmm.
worker nodes. It has to be there always, and basically it communicates with the kube API server of the master node. So basically that connection is like that connection is established by this
Okay.
kubelet. So but by this
Okay.
daemon
Okay. Okay.
process. And so suppose, I mean, this is a very classic example. Like we want to fetch logs from the
Mm-hmm.
pods. So basically, we want to see, okay, what has happened to the application, why it errored out, or basically we want to see the debug logs. So from the pods, because pod has my image, a pod has
Mm-hmm.
my container, has my application. So what happened to that application? So S- So basically, the Kube API server will know
Okay.
via kubelet. So basically, with kubelet, it will get all the logs. It's like a bidirectional communication. Like nodes communicate with the
Mm-hmm.
master using kubelet and Kube API server, and Kube API server communicates to nodes using
Okay.
this kubelet. So uh, I gave an example like fetching logs. So for about the container,
Okay.
about the image of the app. So um, so that's an important point. Like how I mean it's a good interview question. Like how they communicate each other. So like kubelet is the guy. Which is the process which runs and it fosters the two-way communication between master node and the
Okay.
worker
Okay.
node.
Okay.
Yeah, so that is done. This is a etcd. So every Kubernetes cluster will have a cluster. So basically,
Okay.
etcd component. It's a base. Yeah, it's a key value store, uh, and basically it contains the metadata about the cluster
Okay.
data basically. And so Kube API server interacts with etcd. So etcd itself is a
Mm-hmm.
cluster of machines. So basically, but that is a separate that is a, I mean we that is a separate cluster entirely. But I mean uh, when we will have our AWS machines, we will be seeing like there are few machines which are spin up for etcd, and etcd is basically a highly available key
Okay.
value store. So basically, it provides the data
Okay.
persistence. So the example is
Okay.
like pods. So basically, client programs like this Cube API server will interact with
Okay.
etcd, and we discussed it's a different from the actual cluster actually. So it's mostly for consistency and reliability, and um, just theoretically, we should know that okay, the cluster members communicate with each other using a RAF
Trap
protocol.
protocol. Okay.
So yeah, yeah. So that is entirely for the etcd
Okay. Okay. Okay.
cluster. Um, yeah, QProxy. I mean, this is another process uh, which runs on Kubernetes cluster, and we should be aware about what is a
Okay.
QProxy
Okay.
actually.
Okay.
So whenever we receive traffic
Uh-huh.
from the client, for example, classic example, we were running Gatling test. Now we are getting a lot of traffic from the
Uh-huh.
Gatling client. So we should be as a part of performance testing, for
Okay.
example. So basically in the diagram, if you see here, it basically gets the it gets the traffic
Okay.
from the client, and it connects that traffic to the
Okay.
pods basically. So one approach is basically as in the diagram, it's called service. It's called the IP
Okay.
table rules. Um, so basically, it captures the traffic. It captures the traffic and redirects it to the to the
Okay.
relevant pods. So basically, there are pods which are there in the different
Hmm.
nodes. So that work is being taken care. That routing of work is being done by this
Okay.
QProxy guy. Uh, so basically, it handles both the TCP and
Okay.
UDP traffic, and basically, I think you only asked someone asked like who does the load
Yeah. Yeah.
balancing
Yeah.
part. So the yeah, so the load balancing part is
Okay.
done by this guy. So
Okay.
QProxy. So we don't have to worry about this
Hmm.
thing, but we should know what does QProxy does. I mean, who does the load balancing? Because the question might come, okay, you are a DevOps engineer, so do you have to configure the queue proxy by yourself? The answer
Hmm.
should be no, because this load balancing is done by the queue proxy, and uh, so um, I mean that's another interview question.
Okay.
So you should be aware about it. And this is the basically the I think this is the final like we add up all whatever we saw in the previous
Hmm.
slides. Basically in this section there is a
Hmm.
Kubernetes master. So we discussed about the kube API server and kube API server and the kube control
Hmm.
manager and the kube scheduler, and this kube API server in turn talks to another cluster of machines called
Okay.
etcd. So yeah, so basically these are the three important things of master node of the master node. And the this block is basically the worker node. This is also called as Kubernetes
Hmm.
minions.
Minion.
So
Oh, minion.
so yeah, minion. Yeah, it's called
Okay.
Kubernetes minion. We saw it already that we worker nodes or the minions should have a
Hmm.
kubelet and a
Okay.
QProxy running, and these are all like individual nodes, and all these nodes and all these worker nodes which runs the kubelet agent and makes sure basically kubelet ensures that the containers are running and healthy, and basically QProxy who does the routing of traffic
Hmm.
from the end client, so that the and but all these things talk to each other via connector. For example, a company can either use
Hmm.
AWS or Google or Azure. So all these components are connected by a cloud provider or called connect like they are called
Okay.
cloud connectors. So all these like Kube API server processes, Kube Control Manager, Kubelet, they are all talking to the AWS or Google by these
Okay.
connectors. So this is basically a very like detailed um structure
I
architecture
know.
of this
Oh.
Kubernetes cluster.
Hmm.
Any
Okay.
Kubernetes cluster actually. So yeah. So
No,
you
no,
are saying
no.
something?
Nothing.
Yeah. So actually, that's pretty much it
Okay.
for today. I think from now onwards we'll not be having any more theoretical
Okay.
lessons, learnings. So we'll be trying to
Looking into the.
like once you
Okay.
have this, yeah, we'll be looking into the practicals now.